Welcome to this explainer. Look, if you build in Power Apps, get ready because you're about to experience a fundamental paradigm shift. Today, we're moving way past the basics and truly mastering Power Apps' tabular data and UI architecture. We're going to transform the way you handle formulas, datasets, and screen navigation so you can start building lightning-fast, professional-grade applications. Let's jump right in. So, have you ever built a Power Apps screen where the data just looked totally messy, the gallery loaded incredibly slowly, or the user interface just felt entirely unmanageable? Or, oh man, maybe you've encountered those frustrating navigation loop bugs where clicking back just keeps bouncing you right back to where you started. It's a shared pain among developers for sure. Most people immediately point fingers at SharePoint or Dataverse, just assuming the database itself is the bottleneck. But the truth? It's actually much closer to home. Here's the core insight. It all comes down to displaying data directly versus shaping the data payload. A beginner developer usually takes the database and wires it directly into the screen, pulling literally everything, every column, every row. And the result? A tangled, slow mess. An architect, however, shapes the data before it ever even reaches the screen. They filter it, they trim the columns down, and they format it in the background. It's this precise shaping that results in fast, scalable, and beautifully readable apps. All right, here is our roadmap for today. First, the beginner versus architect mindset. Second, shaping the data payload. Third, precision record retrieval. Fourth, modern table to form. And finally, advanced UI and state. Let's dive right into section 1, beginner versus architect mindset. To actually shape your data, you absolutely need the right tools, what we call the Table Function Toolkit. Rather than just a random list of code, these functions group logically by purpose. First up, create functions, like the table function. Generate temporary, in-memory tables for mock data or small lookup lists. Next, we have shape and transform, which features functions to add, rename, show, or drop columns. And finally, extract and retrieve, giving you surgical precision to grab single-edge records, specific positions, or top-end previews. Mastering these groups is exactly how you take complete control of your app's performance. Moving right along to section 2, shaping the data payload. Okay, so the crucial part here is how we handle columns without wrecking our actual database. Take rename columns, for instance. If you've ever dealt with messy internal SharePoint names, those weird internal string values that pop up when a column gets renamed and literally make you want to pull your hair out, well, this function is your new best friend. It standardizes the field name purely inside your formula, so your code stays human readable. Then we have add columns. This one is fantastic for creating derived fields, like, say, combining a first name and a last name into a single calculated display string. It provides exactly what your combo box or gallery needs, all while keeping your source data completely clean and untouched. Now, when it comes to performance, you've got to decide what data is actually traveling over the network. Here, we need to contrast show columns with drop columns. Drop columns is a targeted exclusion. It's low impact, and it's useful if you just want to quickly strip 1 or 2 system columns from a collection. But show columns, that is the professional standard for performance tuning. It represents intentional inclusion. Think about it. If you have an 80-column SharePoint list, but your gallery only needs 4 columns to function, show columns forces you to actively declare that required schema. By trimming the payload weight immediately, you drastically improve your gallery speed. It's a real game changer. All right. Let's look at section 3, precision record retrieval. Look, you don't always need to pull a massive table, right? Sometimes you just need specific rows. For that, we have first, last, and index for single records, and first n and last n for limited sets, kind of like top 10 dashboards. But hey, there is a critical warning here. Using last and last n carries incredibly high delegation risks against large Dataverse or SharePoint sources. A function that works beautifully on 20 records might fail spectacularly on 2,000. The architect pattern here is to bypass last entirely. Instead, sort your data first using sort by columns in descending order, and then use first or first n to grab the safest, most recent items without breaking delegation. And while we're on the topic of specific records, please remember this rule. Business identity is stronger than row number. It can be super tempting to use the index function as a shortcut to just grab, say, the third record in a table. But relying on dynamic positions is super fragile. A record's position changes the exact moment someone sorts or filters the list. Always rely on proper lookups targeting an ID or unique identifier rather than a row position when you're applying your business logic. Let's actually break down the anatomy of a professional formula. We're not just slapping functions together here, it's a very deliberate three-step process. Step 1, filter. We're pulling only the active clients from the source, minimizing the raw records. Step 2, show columns. Immediately after filtering, we trim the payload down to just the 3 fields we actually need. Step 3, add columns. Finally, we wrap the whole thing in add columns to create a UI-friendly, full-contact display string. This is exactly how you shape data before displaying it. You've minimized the data pull, optimized the network traffic, and prepped a clean string for the user interface, all in one elegant block of code. Next up, Section 4, Modern Table to Form. So a super common pattern you see all the time is displaying data in a modern table control and allowing users to click a row to edit it in a form control. This requires a seamless handoff handled through a precise 3-step architecture. First, you set the form's item property directly to table.selected. This passes the context perfectly without needing any messy intermediate lookup variables. Second, you make sure the form's default mode is correctly configured to edit. And third, you trigger the transition by setting the table's onSelect property to navigate to your form screen. It's clean, it's maintainable, and it bridges your controls perfectly. But of course, when you connect these forms, you're going to run into complex data types. Yeah, I'm talking about the notorious person column. By default, it often displays this totally useless inject 0 string instead of a name, which is incredibly frustrating. To fix this, you literally have to overhaul the data card. Unlock it, and for the items property, connect to the Office 365 Users v2 connector using the Search User v2 function to pull actual Active Directory data based on your search text. Then, override the default property to actively pull the user's display value on load and secure the update property to ensure the modified ID saves properly. It's a bit of heavy lifting for sure, but it replaces a broken default experience with a polished, professional look. Finally, Section 5, Advanced UI and States. Okay, remember that annoying navigation loop trap I mentioned earlier? You select an item in a table, go to the form, hit back, and boom, the app instantly bounces you right back to the form again. No way! This happens because the table control stubbornly retains its selection state, auto-triggering the onSelect property the second you return. To break the cycle, we use a state toggle. When you leave the form screen, the onHidden property toggles a variable, let's call it var reset, from false immediately back to true. You bind this var reset variable inside the table's items filter. This rapid toggle forces the data source binding to refresh invisibly, completely clearing the table's selection and safely returning the user to a clean UI state. And what about bulk operations? Say a user wants to select 10 records and update their priority all at once. Well, you need a precise sequence to ensure performance. Step 1, bind a variable to the table's Enable Multi-Select property to allow checkbox selections and temporarily disable your navigation logic so clicking doesn't whisk the user away. Step 2, when the update button is clicked, capture the batch into memory using clearcollect, loading table.selected items into a local collection. Step 3, modify that memory locally. Use update if on the collection to alter the target field for every item simultaneously. Step 4, the single query commit. You push the entire modified collection back to your database using the patch function. This is vastly more efficient than patching items one by one inside some slow, clunky loop. Bringing this whole shebang together really requires sticking to architect best practices. First, performance. Trim early. Always use show columns to immediately drop payload weight before applying any other operations. Second, readability. Keep it human. Look, if you write a complex nested formula today that no one can read tomorrow, that's a failure. Use the with function or collections to break complex logic into readable blocks. Third, delegation. Always design with scale in mind. Never just assume a retrieval function is going to work flawlessly against thousands of records. Pay attention to those delegation warnings and filter your massive data sets smartly. To wrap things up, here are the absolute key takeaways for you. Shape before displaying. Clean, relevant, tabular data is the absolute foundation of a brilliant user experience and fast performance. Design with scale in mind. Factor in your delegation limits right from day one. Trim early and optimize heavy loads. And finally, control your UI state precisely. Master variables and collections to handle complex behaviors like bulk updates and selection resets without ever letting the default controls dictate your app's flow. So I'm going to leave you with this thought. Which Power Apps table function will you optimize first? Will you jump right in and add show columns to speed up your galleries? Or are you going to go fix that frustrating navigation loop right now? The tools are completely in your hands to build apps not just like a maker, but like an architect. Thanks for hanging out with me for this explainer, and enjoy upgrading your applications.